again, item B, intrinsic geometry, exterior algebra in 3D. Now B, item B, part 1, manifold. B, part 1, lecture 9. Construct level curves. You see this is a function f, okay? This is k curves, which the coordinates are x1, x2, and x3. Attention now. This is equal C sub k. For each, in this case, each curve, okay, I have a constant that is called level curved. I want to construct curves around point P. The coordinates of point P are x1, x2, and x3. This here belongs to the manifold. Don't forget, this here belongs to R3. You see? So we have points, okay, in which the Cartesian coordinates, attentional points on the manifold, whose coordinates are x1, x2, and x3. You see? Now, this step one, I will just set Cartesian coordinates at the point P that belongs to the manifold. See? So, point P, gamma of 0, okay, this is 0. Lambda is a real number, okay. This leads to 3 coordinates at the point P, which you call there x1, x2, and x3 at the point P. We did this before in previous lectures. Now, step 2. Also, we did before. I have point P. I use this linear mapping, okay, alpha, then x on P, and leads to point Q. Also belongs to R3. This is also R3. So, Q is alpha, applies to gamma of lambda is equal 0. You see, these are the coordinates, Cartesian coordinates of point Q at R3. Obviously, Q belongs to the R3. I repeated that. Now, step 3. Generate curves, level curves, actually, okay? G sub k, x prime 1, x prime 2, x prime 3. You see, since it's level curve, this is equal to dk. For each k, I have a constant over here. This is a curve around now point Q. Point Q belongs to R3. See? So, this I have curve 1, d1, the constant, curve 2, d2 is equal constant, d3, and so on. Okay? Now, so I'll have these curves, okay, on R3. The curve was mapped, okay, that's important, mapped from the manifold to this point over here. So, step 4, apply the inverse map, as we did before in previous lectures, okay? So, I'll apply the inverse, that's a map, I'll apply the inverse, alpha minus 1. Points of each curve, level curve, dk is equal constants around point Q. Now, this is the inverse linear mapping. You take, for instance, a curve d sub j, for instance. J could be 1, 2, 3, till k. Now, belong to R3, you see, I apply to each point of this curve, so this generate points around the manifold, just from this linear operator, alpha minus 1. Now, you see, I would like to emphasize that f sub j is a level curve which the constant is c of j on this place over here, the manifold. Now, the coordinate, attention now, at P, there are Cartesian coordinates that belongs to the Euclidean space. So very, very important. I emphasized in previous videos, just saying that these are Cartesian coordinates, okay, at the manifold. See, that's important. Now, step 5. Repeat step 4, okay, for several level curves around P. Several curves around P. You see, I will have several curves over here, okay? Just apply the inverse, the map, the linear map inverse, then I generate points on the manifold, okay? Those are, in this case, level curves, okay, obtained from this space over here. You see? That's quite clear. Attention now. For points of the level curves, you see, f sub j is equal constant, okay? F sub j, attention, depends on x1, x2, x3, which belongs to the Cartesian coordinates belong to M3. That's I'm insisting, okay, in saying that all the points over here belongs to the Cartesian coordinates, okay? Again, you see, clearly, this I have a point P over here, okay? Now, attention now. You remember, previous lecture, I just obtained the vector space, okay? And the vector space, I have points which approximate points on the manifold to it. You see, we can see clear. I already mentioned and emphasized this a lot. Okay. Now this I wrote here the red coordinates. The red coordinates are approximated points from the manifold represented by Cartesian coordinates to the Cartesian coordinates over there. So this is this case, okay, is a vector space. Now it's important for you to realize that this point here, the red coordinates, belongs not to the manifold, but now is, again I repeat the word, they are approximated points from manifold to, this case, the vector space. Okay? And this particular case for M3, this is a tangent plane. Now, you see, each point on the manifold over here, each point will have its own tangent plane. See, let's call P, P1, M. You see this in here, T, P2, M, and so on. Each point here, I will do the same approximation that I did over here. Okay, do you remember? Lambda is plus epsilon and minus epsilon, and this is lambda is equal 0. So then I can generate any curve that contains this point P over here. Okay, just as I did before. So there are no news, okay, about what I'm saying here. It's good for you to grasp this important concept about manifold, okay, in intrinsic geometry. That's clear.